Alright, so this worksheet I'm going to talk about ionization energy and electronegativity worksheet. So ionization energy, we have the abbreviation is IE, and electronegativity, we have the abbreviation is EN. So first, let's see the definition. Now, IE is the energy required to remove electron from a neutral atom. So it requires how much energy to remove, or like you say, you lose the electron. Right? Remove just kind of like losing from a neutral atom. So if the IE is high, what does it mean? If the IE is high, then the energy required to remove the electron is high, because this is the definition for IE. So if you need to require a lot of energy to remove the electron, that means to be less easier for you to remove the electron, because you need to go provide him a lot of energy to remove the electron. That must be less easier. Now the EN on the other hand, like electronegativity, is with the TY, is actually the ability of the atom in a chemical compound to attract electron, Ability, like are you able to attract a electron in the chemical compound? Now you can think about attract just kind of like gain. Okay. Now what if the definition of EN is high? If the EN is high, that means the ability to attract electron is high, right? That's the definition of EN. So what does that mean by ability to attract electron is high? That means you are able to attract electron. If you're able to attract electron, it means that it's more easier for you to attract electron. Now you say that I box all the way remove for the IE, I box all the attract for EN. Now I'm not worried about you got confused for energy with ability, because you can name like this ionization energy is energy required, and this is ability. It's ability. Right, how much ability you can have to attract electron. What I'm worried about is you may confuse remove from the attract. So I think about like a short phrase is IERENA. Ionization energy is remove, electronegativity is attract. IERENA. Now we have two important messages here. IE includes noble gas. IE includes noble gas because noble gas is on group 18, which is like cannot remove electron, because noble gas is already full. You cannot remove electron. But now you're talking about, hey, you cannot remove electron. I'm going to require you to give you like a lot of energy, right, to help you to remove electron, because that is the IE. IE is the energy required to remove electron. Noble gas cannot remove, but if I force you to remove, you must give me high energy. So it turns out that IE will include noble gas. Well, actually, the noble gas has the highest IE because they are the least easier to remove electron. You cannot remove electron, but you have to force them. Then you have to give them the highest IE. Now, on the other hand, EN does not include noble gas. EN does not include noble gas because EN is ability for the atom to attract electron. Now, noble gas never have the ability to attract electron. Never, because they are not able to attract electron at all. So I'm not even say zero ability. I would say they never have ability. So in other words, electronegativity will not include noble gas. They will stop at halogen 17. After halogen, no more IE. But IE will include the whole periodic table. Now we're going to start again talk about down the group. Now remember we say down the group, right? We got a nuclear shield, and we're going to take over, because nuclear charge talking about proton versus electron, and nuclear shield is talking about shell, talking about barrier. So when you go down to the group, you have more and more shells. So nuclear shield is going to take over. So nuclear shield is going to be increased. So when you have more and more shells, attraction is going to go down, right? Very easy to imagine when you have more and more shells down the group, less and less attraction because so many shells. So on the other hand, if I go across the period this way, you're going to have nuclear charge take over, because nuclear charge talking about the difference between proton and electron. So across the period, you have more and more proton, more and more electron. You're going to have more and more proton pull the electron closer. So then the nuclear charge will be the factor when you go across the period. So then you bring your electron closer and closer and closer, then the attraction is high. So it's very easy for you to imagine down the group. When you down the group, you have less and less interaction. So then when you go across, will be more and more interaction. So if you combine two together, you will actually find that attraction when you go down is smaller and smaller. Across will be bigger and bigger. So we're going to form actually this attraction trade. You're going to form this attraction trade. Okay. So here is the IE, here is the EN. So let's talk about down the group. Now when down the group, we have less and less attraction. Right? Now IE want to remove electron because we say IER. IE want to remove electron. So when you have down the group, we have less and less attraction. Okay, I want to remove electron, but I have less and less attraction, then it will be more easier for me to remove electron. You can say more easier for me to lose electron, but we're going to use remove because attraction is less and less, so then it's kind of like losing. Very easy for me to remove electron. If more easier to remove electron, then I don't need to give you a lot of energy. Okay, I get the job done very easily, so I don't need to give it the energy much. Then I would say less energy required to remove electron. If less energy required, that means my IE is going to go down when I go down the group. Now on the other hand, ENA, right? EN is going to do attract electron. Now when you go down the group, attractions go down and down. Attractions go down and down. So when attraction go down, will be less easier for me to attract electron. Because attractions go down and down, less easier for me to attract electron. There will be less ability to attract electron, because this is the definition of EN. Less easier to attract electron, less ability to attract electron. So then my EN will go down. So as a result for down the group, ionization energy will be down the group, ionization energy will be decreasing, and electronegativity also be decreasing. When you go down and down, they're getting smaller and smaller. So the bottom element will require lower IE and less EN than the one on the top. Okay? Now, on the other hand, right, we just talked about across a period, attraction is higher and higher, higher. So IE want to remove electron. So when you go across a period, you want to remove electron, my attraction is going to be higher and higher, higher. That would be less easier for me to remove electron, because when you go across, it's going to be high attraction. That means you guys are really tight attached. I want to remove you, it's not easy. So it will be less easier. If less easier, I will need to provide you more energy to do the job. The more energy to remove the electron, the IE is going to go up when you go across the period. And then on the other hand, right, when you have EN want to attract electron. So across the period, when the attraction is higher and higher, all right, I want to attract electron. Okay, fine. That will be more easier for me to attract electron. There will be more ability to attract electron. So then the EN is going to be high when I go across the period. So as a conclusion, across the period, ionization energy will be increasing. The electronegativity will be also increasing. And so then the one on the right-hand side, the one with the higher-hand side, will have higher IE and more EN than the left-hand side. Okay? Now the back page, okay? Because both the EN and the IE, they have the same thing. Down the group will be decreasing. Across the period will be increasing. So when you think about down the group, decreasing is going to be smaller and smaller. That means across will be getting bigger and bigger. So when we draw the IE, it's going to go like this trend, okay? Small to big. And IE will need to include noble gas. We need to include the whole thing. Now EN has the same trend, small to big, okay, small to big. But EN does not include noble gas. We just say that noble gas does not have ability, never have ability. So here we'll be waiting a shorter trend. We will stop at 17, okay? So here we just draw the same trend, all right, small to big. We arrange the elements and increasing of IE from small to big. So small to big, we start from CA all the way to NE with this symbol, okay? Now here, which element has the highest ionization energy, including noble gas? Again, we say the IE will include noble gas. So if you want to try to solve this problem, you got to draw the IE trend. Draw the IE trend, the black one, small to big, all right, and this IE. You're going to draw this trend, imagine that you put this whole trend onto the whole periodic table. Which one's going to be highest IE? So that should be the top, far right, which is HE. Because HE is going to be right here. Let me show you the periodic table. Right? So the trends go like this way. HE is the high, like top, far right hand side, which is the highest IE. Okay? So how do you explain that? First of all, besides we draw the IE trend, we also want to draw the attraction trend. We say that when we go down to down, will be less and less attraction. So this will be the trend, the green color. So we explain He has the highest ionization energy, including the noble gas, including the whole thing, because it is on period 1. Okay, He is on period 1. Okay, so when you think about on period 1, you want to compare to period 7. Okay, think about period 1, think about period 7. So period 1 is right here, right? This is the whole period 1, and then on the bottom which is period 7, which is this thing. So you think about from period 1 to period 7, you're actually thinking about up and down vertically. So if you think about up and down, you're actually thinking about shielding, because up and down is talking about barriers. So nuclear shielding is going to be the lowest. Now, why is lowest? Because we say that when we go down to the group, you have more and more shells, right? Period 7, more and more shell. Shielding is going to be highest on the period 7. But He is on the period 1. If go down, down, down is highest on period 7. On the other hand, He period 1 must be the lowest shielding, because on period 1, you only have one shell, then the shielding will be the lowest, just one shell. So here, the nuclear shielding is going to be the lowest because on period 1, right? Because period 7 will be the highest. It also is on group 18, okay? Helium is on group 18. So when you think about group 18, you want to think about group 1. Okay, so you're thinking about from group 1 to group 18, it's going to be horizontally. Okay, so think about between group 1 and group 18 will be horizontally. Now, horizontally, nuclear charge will be take place. Now, group 18 is on here, helium is on here. Now, nuclear charge is going to be increasing and increasing when you go across the period. So what will be the nuclear charge for He on the group 18 should be the highest, because the nuclear charge is going to be increasing on across the period. And the He is the last group of far right. So then nuclear charge is going to be the highest. Now, as a result, what will happen to the attraction? Now, if you draw the green color attraction, if you imagine this attraction is also going to put on the whole periodic table, He will be like somewhere on here. That means the attraction must be the highest, because it's the biggest side. Attraction must be the highest. So IE, what IE want to do? IE want to remove electron because IER. So if the attraction is highest, I want to remove electron. This is going to be the least easiest, because the attraction is highest. That means you hold me really tightly. That means it's not going to be less easier. The least easiest to remove electron, because you're so tight. If you have least easiest to remove electron, I need to give you the highest energy to remove electron, because it's least easier. It's not easy. I have to give you the highest energy to remove electron. So in the other word, He will have the highest IE, including noble gas.